This will be for the Khan Academy exercise, writing functions with exponential decay. All right, some quick notes. Remember the basic exponential equation, that is y equals a times b to the power of x. Remember that a is your initial or starting amount. B is what you multiply by each time. Okay, that's the number that gets the exponent. And remember that the initial amount is 100%. In terms of a decimal, that equals 1. If you want to add or remove a certain percentage or fraction from the initial amount, you add or subtract from 1 and use that number to multiply. Okay, for example, if you want to remove 5%, you're going to multiply by 0.95. Okay, because if you do 100%, which is 1, minus 5%, which is 0.05, you'll get 0.95. So when you multiply by 0.95, that will remove 5%. Okay, for the fractions, if you want to remove 2/3, you multiply by 1/3. Okay, because 1 minus 2/3 would be 1/3. So to remove 2/3, you multiply by 1/3. All right, it says here the moment a hot iron rod is plunged into freezing water, the difference between the rod's and water's temperature is 100 degrees Celsius. This causes the iron to cool, and the temperature difference drops by 60% every second. Write a function that gives a temp difference in degrees Celsius, T seconds, after the rod was plunged into the water. All right. So what is the initial amount here? Well, we're looking for the function that gives the temperature difference. All right. And the temperature difference when we first started was 100 degrees. All right. So remember the function, exponential function, is in the form of y equals a times b to the power of x. Okay, we said a is the initial amount. In this case, it's 100. So for a, that's going to be 100 times. Well, what exactly happens here? The temperature difference drops by 60% every second. If you want to remove 60%, remember, you start with 100% and you want it to drop by 60%. That leaves us with 40%. Okay, but you can't multiply by 40%. You need to convert it to a decimal. If you move it over 2 places, that's going to be 0.4. Okay, so this multiplying by this right here, that removes 60%. So this is going to be times 0.4. Okay, if you don't like the dot, you can use parentheses. Either one works. Because you multiply by 0.4 to remove 60% every second. Okay, and t is the number of seconds, so t is going to be the exponent. And why is that? Because every time a second goes by, this exponent increases and you multiply by 0.4. You start with 100 and you multiply by 0.4. That's after 1 second. Okay, then you take that number and you multiply by 0.4 again. That's after 2 seconds. Okay, and it keeps going. Every time you multiply, every time a second goes by, you do times 0.4. It makes it drop by 60%. Okay, so instead of writing 0.4 over and over, you just use that exponent on 0.4. All right, so t is the number of seconds and it drops every second. So that's going to be the answer. All right, 100 times 0.4, and I use shift 6 to get the exponent t. Okay, shift 6 is the caret symbol like that. It'll help you do the exponent, or you can just click on this menu here and get the exponent that way. But 100 times 0.4 to the t. All right, so A hot cake is put in a cooler. The difference between the cake and cooler's temperature is 50. All right, this causes the cake to cool, and the temperature difference loses 1/5 every minute. Okay, write a function that gives the temperature difference in degrees T minutes after the cake was put in the cooler. Okay, once again, the basic exponential equation is y equals a times b to the power of x. A is the initial amount. We're writing the equation for the temperature difference. It said the initial temperature difference was 50 degrees Celsius. Okay, so the initial amount, A, is 50. And what are we multiplying by each time? Well, it's going to lose 1/5 of its value. Okay, so this is 100%, but we said at the beginning 100% just equals 1. Okay, so you start with 1 or 100%, and it's going to lose 1/5, so it's minus 1/5. All right, 1 minus 1/5, 1 is the same as 5/5 if you want to use a common denominator. And then minus 1/5, well, 5 minus 1 is just 4. So if you multiply by 4/5, if you do times 4/5, it's going to make it lose 1/5. All right, so let's do times 4/5. And we want to do times 4/5 every minute. Okay, and we said t is the number of minutes, so the exponent is just going to be a t. All right, so basically you start with 50, and then after the first minute, it's times 4/5. Okay, that's after 1 minute. And then you take that number and you do times 4/5 again, and that's after 2 minutes. And so on. Okay, every time you do times 4/5, every time a minute goes by, you do times 4/5, and it loses 1/5. So that's it right there. All right, 50 parentheses 4/5, hit tab, close parentheses, and shift 6 for the exponent. The exponent is a t. 50 times 4/5 to the t.